Hi fellow mathematicians, you are welcome to John Calculus Maths class. So today in this video we'll be evaluating this brilliant integral, this definite integral which has a limit from 0 to 1. You can pause the video if you want to try it yourself. When we observe in this video, you'll be thinking on how to start this integral. Well, maybe you start from your partial fraction first, or you just have to apply your use substitution first. But believe me, fellow mathematicians, I will do on my voice. Believe me, fellow mathematicians, I will bring a great solution to this brilliant integral here, and I hope the solution will be helpful. I will definitely get to a brilliant answer to this integral. So what I just have to do, I think I just have to let this guy be my u. You can use your u, you can use t, anything you want to use, you can use a dog. So I'll just let this guy to be my u. So I'll say let u equals to x plus 1. Let my u equals to x plus 1. So I have my du equals to dx. But when we notice in the denominator we are having x squared plus 1. So we just have to solve for x. So I have been having u minus 1 equals to x. But now, from our limit 0 to 1, remember our limit is x approaches 0 and x approaches 1. But now we are using our u, so we have to change it. So now I have x approaches 0 for my lower limit. Now my u is equals to, now my 0, when I plug in my 0 into my x, 0 plus 1 will give me 1. So I have my x approaches 1. When I plug in my 1 here, 1 plus 1 will give me 2. Now our limit now will be u approaches 1, u approaches 2. So I'll bring my limit for my lower limit, which is 1, and my upper limit 2. Now my dx is nothing but my du over. Now all of this guy now is my u. So I'll bring my u bracket. Now we have to solve for x. Now remember, in this side we are having x squared plus 1. So when I fix in all this guy into my x here, all this will be raised to the power of 2. So I'll be having u minus 1, this power of 2. Don't forget my plus 1. Plus 1. You see? So I'll bring my integral from 0 to, so from 1 to 2, I have my du over my u. So when I factorize this or I simplify this, we'll be having nothing but u squared minus 2u plus 2. Now in this side now, I will just apply my partial fraction. I just have to apply my partial fraction. So let me draw a line here. Yeah, I just have to apply my partial fraction. So I'll be having a, with my marker. Let me change my marker. I'll be having a over u plus bu plus c over u squared minus 2u plus u. So I'll be having a bracket u squared minus 2u plus 2 plus u bracket bu plus c equals to 1, because this side here is constant. So my a will multiply everything here. A times u will give me u squared. A times minus 2 will give me 2 minus 2au plus a times 2 will give me 2a. U times bu squared give me, u times b will give me bu squared. U times c will give me u c equals to 1. So in this side now we just have to collect our like terms. We just collect our like terms in this place, which we are having a plus b, because a u squared and b u squared, they are like terms because they have the same thing. So which is equals to 0. Now the coefficients of u squared is 0. So I take my other like terms again, which is minus 2a, and I have plus c. The coefficient of u is 0. Now the other one, we'll just left with our 2a, which is equals to 1, because my a is constant and my 1 here is constant, so my 2a is equals to 1. So therefore my a is equals to 1 over 2. This for my a. Remember, this is my equation 1, equation 2, and equation 3. Now we've already gotten our a, so have to find our b from our equation 1. When I plug in my 1 over 2 into my a here, we'll be having 1 over a, 1 over 2 plus b equals to 0. Therefore b equals to minus 1 over 2. You see, this for my b. Now I have to find for my c. From my equation 2, we are having minus 2 bracket 1 over 2 plus c equals to 0. Yeah, 2 cancel 2, we are having minus 1 plus c equals to 0. Therefore c equals to 1. You see, this for my a, b, c. A equals to 1 over 2, b equals to minus 1 over 2, c equals to 1. So now we just have to fix all of this into our integral now. So from let me just put it here, equals to, what is my a? My a is 1 over 2. Then my integral, don't forget our limit from 1 to 2. And I have 1 over u du. Then what is my b? My b is having negative sign, minus 1 over 2. Then my integral from 1 to 2. Remember, my b has u, have my u. Oh my god, this space won't be enough. This space won't be enough. Just clean this off so we have enough space. I don't want to over squeeze it there. So my a, 1 over 2, my integral 1 to 2, then my 1 over u plus du minus 1 over 2. I have my u over u squared minus 2u plus 2. I have my du. Then for my c is just 1. So my 1 over my 1 to 2, 1 to 2, just du over u squared minus 2u plus 2. You see, now I'm going to evaluate for each of them. We'll be evaluating for each of them. Now let me call this my IA, and let me call this my IB, and let me call this my IC. Now from my IA here, from my IA, which is equals to 1 over 2, from 1 to 2, and I have 1 over u plus u. We all know that the integral of this is nothing but 1 over 2 ln u. Then my limit from 1 to 2. From 1 to 2. From 1 to 2. So I just have to plug in my limit. So my 2, I'll plug in my 2 into my u. We'll be having nothing but 1 over 2 ln 2. When I plug in my 1 into my u is 0, so don't have to write it. So therefore this is equals to my IA. Now let's go for our IB, which will have my IB here is equals to, don't forget your negative sign, minus 1 over 2. I have my u du over u squared minus 2u plus 2. I have my minus 1 over 2. I have my u over u minus 1 squared plus 1 du. So in this side now, I just have to apply my substitution. So let me use my t. I'll say let t equals to u minus 1. Then my dt, so my dt equals to du. We are having from 1 to 2, then from 1 to 2. dt, don't forget in our numerator here we are having u, so we have to solve for u. I have my t plus 1 equals to u. Now we have to change our limit also now. Remember, our u approaches 1, u approaches 2, but now we are using our t. So let me just put it here in bracket. My u approaches 1 for my lower limit. Then my t equals to, when I bring in my 1 into my u, 1 minus 1 is 0. Then my u approaches 2. T equals to, when I bring in my 2 into my u, 2 minus 1 is 1. You see, we've changed it now. So from this side here, from this side, I have my minus 1 over 2. Then my integral from 0 to 1. Then what is my u? It's nothing but t plus 1 over all this guy here is equals to my t. Remember, it's raised to the power of 2 plus 1. I have my dt. Hi, fellow mathematicians. In this side, we have to split our integral into 2 again. We just have to split the integral into 2. So we'll be having minus 1 over 2. My integral 0 to 1 t over t squared plus 1. Now I have my plus my integral 0 to 1. Now I have my 1 over t squared plus 1. Now I have my dt. So I think let me just call this my gamma and let me call this my g. Very interesting. This is my gamma and this is my g. Now for my gamma, which is equals to minus 1 over 2 integral 0 to 1 my t over t squared plus 1 dt. Now we'll apply our substitution once again. Now I'll be using my v. Let v equals to t squared plus 1, and here I have dv equals to 2t dt. So let me continue from this side here. Then here we'll be having dv over 2t equals to dt. So now we just have to change our limit again, because now we are using our v. We have to change the limit. So let me put it here in bracket. Remember, my t approaches 0. Then my v equals to, when I bring my 0 into my t, 0 raised to power 2 is 0. 0 plus 1 is 1. Then my t approaches 1. When I plug in my 1 here, 1 raised to power of 1 is 1. 1 plus 1 is 2. So my v equals to 2. Wow, I think I have to clean this side. So we move further. Sorry. I pipe up this. So I think from this side, let me continue from here. So I bring my integral. Remember, we're having minus 1 over 2. So I have my minus 1 over 2, and my integral from 1 to 2. Then we are having my t over all this guy that is nothing but my v bracket. This my guy. Remember, my dx, my dt is nothing but dv over dt over 2t. dv over 2t. Now my t, we cancel my t. You see that my 2, we multiply this, which is nothing but 1 minus 1 over 4. And I have my limit from 1 to 2. Then I'll be having 1 over v dv. Now the integral of this is nothing but ln v. So I have to plug in my limit, which is 1 to 2. So when I plug in my 2 into my v, it's nothing but minus 1 over 4 ln 2. When I plug in my 1 into my v is 0, so we don't have to put it. So remember, this is for my gamma. Hey, fellow mathematician, this is for my gamma. Now we have to go for my g. Now for my g, it's a very simple one. We all know this. Now for my j, which is equals to minus 1 over 2, then my limit from 0 to 1, and I have my 1 over t squared plus 1 dt. We all know that this is nothing but the inverse tension, the inverse of tan, the inverse of tan of t, the inverse of tan of t. So I have to plug in my limit. So when I plug in my 1 into my t, the inverse of tan 1 is nothing but pi over 4. Oh, sorry, I forgot to put my 1 over 2. The inverse of tan 1 is nothing but pi over 4. So I have my minus 1 over 2, and I have pi over 4. When I plug in my 0 into my t is 0, so I don't have to put it. So therefore, this will be nothing but minus pi over 8. Nothing but minus pi over 8. So this for my g. So we are left with our c now. We have to evaluate for c. That is the last one. I think, yeah, that is the last one. So let me just clean this off. Yeah, let me just clean this off. So we evaluate for our c. So let me do my IC. Let me put it here. We are having my integral 1 to 2 du over u squared minus 2u plus 2. So we're having my integral 1 to 2. I have my du over bracket u minus 1 square plus 1. So now let me use w. Let w equals to u minus 1, and I have dw equals to du. So now I have to plug in my limits. Remember, my u approaches 1, and my w equals to 0. My u approaches 2, then my w equals to 1. So let me continue from this side here because of space. Now I'll be having my limit as 0 to 1. Then what is my du? It's nothing but dw over all of this. Now all of this guys nothing but my w. Remember, it's raised to the power of 2 plus, then we're having plus 1. Now we all know that this is nothing but inverse of tan of w. Now I have to plug in my limit. When I plug in my limit to my w is nothing but pi over 4. So this is nothing but 0, so we don't have to write it. Remember, this for my IC. Wow, nice one, fellow mathematicians. Now what we have to do next, we are almost done with this. I'm telling you, we're almost done with this. Now we just have to combine everything together. Let's see what we are going to end up with this. So let me just clean from this side. Let me clean from the up side here. So you see it clearly. Now we are having, let me put it in a bracket like this. For my IA, we are having 1 over 2 ln 2. Then for my IB, remember we first evaluate for gamma first, which is minus 1 over 4 ln 2. Then for my J, which is minus pi over 8, then plus pi over 4. You can see it, plus pi over 4. Now in this side, now we just have to simplify this to a smaller form. So from this side here now, let me just take the LCM. I'll be having 4 here, then divided by this, I'll be having here is nothing but nothing but 1 over 4 ln 2. Then from this side here, let me take the LCM of 8. Now 8 divided by 8, it gives me pi. 8 divided by this, it gives me 2. 1 minus, yeah, there will be nothing but pi plus pi. Yeah, there will be nothing but plus pi over 8. So in this side again, I can still break it down. Let me just take the LCM of 8. Now 8 divided by 4 will give me 2. 2 times 1 is 2. ln 2. 8 divided by 8 is 1. 1 times pi is pi plus pi. So, fellow mathematician, this is our final answer to this bad guy here. I hope you enjoyed this video. It was really great. Yeah, I just have to take my time to create a nice solution to this integral, and I hope this is helpful for you guys. Wow, it wasn't easy. So, a minute. Yeah, I just want to recommend this book, University Calculus. Yeah, University Calculus. Yeah, from Will Thomas. Yeah, you can see it. Yeah, this textbook is really great. Wow, it's too heavy. Very heavy. I don't know why all the calculus textbooks are very heavy. I really don't know why. The calculus textbook is heavy. The problem also is very heavy. I'm telling you. So if you can get this textbook, it's very great. It's very great. It will make you to improve more. You see most of the things you need to know in calculus. So that is it. Thank you, fellow mathematician. Please don't forget to subscribe to my YouTube channel. Click on the bell icon so you'll be notified anytime I post another video. So please, thank you. See you next time.